variables. This is our second module. In variables, we'll see their different assignment, which we are calling as a variable assignment. Now we said x is equal to 10. So when we call x, we can get this 10. This x is a reference for human. This x is a reference for us. We have given reference x so that whenever we need this value, we can call x and we can get the answer. But how Python is calling this 10? Because Python does not know English. Python cannot understand what do you mean by x. Python will consider this x as one address on memory. So actually it will not deal with your x, it will deal with this number. It will say, okay, so I will assign one memory location for this 10. Python will say, I'll assign one memory location. This memory is obviously your volatile space, which I can read as a RAM. So this 10 will be assigned to your memory space, where you can see that this is pointing to some number. This is pointing to some number. As soon as I say y is equal to also 10, what do you say? This 10 will have a separate memory, or this 10 will also point to the same memory. Because both memory address is same, they will be pointing to the same memory because both are same value. Just identifier name is different for us. If I want to use x separately, I want to use y separately, I can use them. Then there are different types of typecasting. Can I convert from integer to float, float to integer, string to float? Likewise, all this part we'll see in this module, which we are calling as a variables in variable assignment. So let's start with the variables. A variable is a location in memory used to store some data value. Okay, so a variable is a location in memory. We're calling this as a variable. A is a variable, B is a variable, 10 is a value, right? So this 10 will store some address in memory. Similarly, this 10 will also store some address in memory. We'll see that how we are assigning it. Few other statement. They are given unique names to differentiate between different memory locations. Obviously, if I type same name, they will first override. And if I need them, how can I call my individual variables? That's the reason we'll be calling or giving them a separate name. The rule for writing a variable name is same as the rule for writing identifiers in Python. Exactly same. That you can have lowercase, uppercase, digit after any word, not before any word, as in you cannot start any variable name with a digit. And from special characters, only underscore will work. We have seen that in our previous video. We don't need to declare a variable before using it. In Python, we simply assign a value to a variable and it will exist, right? As in other programming languages, we define this is integer, this is a string, this is double. We will not be talking all those things here. Python compiler will understand internally whether this belongs to integer or a string or which data type. We don't even have to declare the type of the variable. This is handled internally according to the type of value we assign to the variable. Now, variable assignments. A is equal to 10 and B is equal to 10. Now, if you print this A and B, so you'll get 10 here because this A, this 10 will be mapped here. First line print is A answer is 10 and B answer is also 10 because this 10 is also mapped with this B variable. Then second, you are typing ID. This actually ID is talking about their memory locations. So let me write it here. This ID is created to check memory location of variable A, and similarly for B. When I type this print ID A and print ID B, since both are having the same name, their address of memory location is exactly same. That's what I have graphically noted here as in flow wise. If X is 10, Y is also 10, both will point to the same memory because if I store separate memory location for both the variable, then I'm not utilizing my spaces properly. For if suppose I have millions of 10, then all the time they will store millions of address for all this 10, which is not a good architecture style or design. So in Python, this is the by default nature. If you have changed, you have given one value to variable and same value you're defining to another variable, both will point to the same address. And to check that, we have a function called id. My third variable is b is equal to 20. Now here I'm trying to overwrite it. Here I'm trying to overwrite it. Because if I say b20, b is already 10. If you check this line, b is already 10. If I write 20, then b will be written as 20. Now if I'm checking their id, so obviously this id will change and I will have a separate id for b, because now this is the memory location for 10. This was memory location for 10. Now this is for 20. But if you can check, this is going in sequence, in incremental or ascending order, right? This is we keep going in your memory. After this id, I'm writing print b answer. So what is the current answer of b? 10 is overwritten by b, hence I'll get this 20 as answer. And a is not affected, a is same as earlier, which is 10. So this is how you can define your variable assignments. Next part. Here we'll see some sort of type conversion also. So a is equal to 10 and d is equal to 10. If you check this two element, a is 10 and d is 10. Again, both are same numbers, okay? Or I'll start reading them now. So whenever you see any value which are absolute value like this, 10, 20, 50, 100, 1000, we call them, this is integer. This is also integer. If you see some number with decimal, if you see some number with decimal, this is what is float. So from now on, you start remembering, if you have any absolute number, that is integer. If you have number with a decimal, this is float. If you have anything within single quote or double quote, this is known as a string. So these are your initial data types: integer, float, string. We'll see one complex number also, which are a part of number, but often we'll be dealing with this integer and float. Complex number is very seldom I have used it in practical. Now let's start from here. A is 10, D is 10, B is 5.5, C is ML. We know what is their data type. Compiler will not ask us explicitly to define, it will understand internally also. We have many feature, we have this kind of feature available in other programming languages also, like Scala. I've used it. In Scala also, I don't need to define this value is from which data type. Okay, so it gives you kind of flexibility. There has a pros and cons also. You're not writing it, but if somebody is reading and if this is written as integer, then the person knows, okay, this is integer. So it has pros and cons both. When I type print id a, I'm getting this address. I'm typing print id d, again I'm getting one address. And if you check this address is exactly same, because as soon as you say a10, it will store this 10 in some memory, and this is the number. If you type d equal to 10, again this d will start pointing to same memory. Then you're typing float d. Check the third print statement carefully. You're typing printed float d, which means what you're trying to do. This d is a earlier type of integer. This d is earlier integer, and you're asking from integer, convert this value from integer to float. That's what it means. If you're typing float before this variable, and then you are giving this variable name here, this is you're trying to convert from integer to float. Can I call this as a type conversion? You're trying to convert the type along with their values also. Obviously value will change, because if you're calling 10 in integer. This is absolute value. If this is converted to float, then this will be 10.0, right? If it is 15, you will get 15.0. Any number in integer, once this converted to float, you get dot as in decimal and then some value, which is 0. So here we'll see, when you type float d, you can see 10.0. This is what I'm talking about. So first type conversion from integer to float. Then second value, you're getting x equal to float a. Now this 10 is also integer and you're converting it from integer to float this way. Same thing you're doing. And again, the value is 10. So 10 will convert in 10.0 and x will store it. So let's read like this. If x is equal to float a, then x is equal to float a, means this will be stored as 10.0. Same thing happening, 10.0, and when I'm printing this x, then I will get this 10.0 as answer, which is this line, fourth line. And now when you check their address, so printing is done, you're checking the address of x. Address of x will definitely change, because integer address, if I check address for this and if I check address for this, both the address cannot be same. Both are different data type. This is integer, this is float. So address will change, guys, in this case. Okay, because how memory is referring, where there is storing, those things will also change. After that, we are checking their type. So type is another function. All this you're seeing id, float, this is by the way data type. Float, id, type, this is all inbuilt functions. Print, so type is telling me which type of data is it. So type will explain you whether this is belonging to integer or float or string. You get this information from these functions, which is type. So I'll start from here, my type function. When I print type, I'll be getting below answer. When I print this type x, I'll be getting this class as answer, class float. I said b is equal to 5. And can you see this 5? This is in double quote 5. Okay. So since this is in double quote, if I print, I'll get the answer as 5. But when I check what type of data is it? Is it a integer or a string or float? This is in double quote. If it is in single quote or double quote, both the time, I will get their data type as str. Str stand for string, string as an answer. So this is this 4 lines, multiple lines of printing and value assignment to a variable. We are closely checking here two things. First, how to get their memory location. Is their memory location same? If uh, both the values are same. If we are converting their type, how can we do that? How can we print? How can we check their type of data? So basic operations we are running in the cell number 1. Here 2. So one thing to notice here, when you're doing type conversion, I will tell you few things will work, few things will not work. Okay, which is not supportable by or supported by your interpreter itself. So type conversion, we should often write this type of note, which will help us to remember this basic grammar of Python. So first, type conversion. You can convert from integer to float. You can convert from integer to string. You can convert from float to string. You can convert from float to integer. You can convert from float to integer. But you cannot convert a string to float for certain value. I will tell you that value. I'll give example by the way here. You cannot even convert from a string to integer. This operations will These two operations will work for some cases, will not work for some cases. We'll see. Rest everything is fine. So first I will try to convert integer to all the types, then float to all the types, then string to all the types, and we'll try to see how it defines. First I will take a number, let's say 5, and I'm trying to convert this 5 to float, and then I see their type. 1 second. Yeah. So I'm not storing this currently. That's why this is giving me the output of integer only. If you want to print here, if you want to write like this, so this is sometimes confusing. That's why I will write it clearly that you're first converting them, writing their output to A2, and then you're checking their value as E2. And this time it should print me float. Okay. So what I'm doing here in this line, I have created one number 5, which is integer, and trying to convert this integer to float and storing this output in new variable called A2. So I have converted using float A1, which means this is converted to 5 is converted to 5.0, and 5.0 is stored in this variable A2. When I'm printing this A2, I'm getting this answer. When I'm checking the type of A2, what is the type of A2, I'm getting float as answer. Sometimes what happens if you type this directly inside the bracket here, you will get 5.0, but if you try to print the type, it does not have a store anywhere. Okay, what it is not stored anywhere that where this output is storing. That's why it return you this answer only. So that's sometimes confusing. That's all right. This thing I'm writing first 5, then converting, storing that output in another variable, printing that variable, and checking the data type. If you want to check all effectiveness of your type conversion. So integer to float is fine. Can I check with integer to string? Integer to string is also fine. Can I check with float? So float is defined and this is integer. So float to integer. But one thing is important here. If it is 5.0, it is giving you 5. How about if A1 is 5.9 or any other with a decimal 5.45, something like that? So if you're converting any float, remember this is important point. If you're converting any float to integer, this decimal value will be discarded straightforward. This decimal, whatever is there, dot 9, as in dot 1, decimal 5, decimal 09, anything is there after decimal, this will be excluded or discarded, and it will be considered as just 5 if it is integer. If it is 6.7148 and you convert this float to integer, it will say just 6. This decimal value will be discarded. So remember this while doing float to integer conversion, whether you are reaching to the right expected output or you're doing some mistake there. Okay, so this is good. Then can we change this to a string also? Yes, perfect. Now, but 1 second, why this is okay. So this is stored in a string as in double quote. If I say 5.0, if I say str, what A2 is having, A2 is having internally answer like this. This is in a string, okay, because double quote, I can read it as a string. After that, if I try to use this, let's say this is 5, and then I convert this to integer. Will it work now? Perfect. So string to integer is also fine. Can I convert this to float? This is also fine. But if you change this to, let's say, some sequence of character, you said hello, and then you try to convert. Obviously, it doesn't make any sense. This is not logical. If you type hello, if you type hi, we do not understand this. Because if somebody asks me to convert this hello to some numeric form, some numeric value, then how can I How can I convert this hello to some numeric value, right? So this is what is a problem, not logical also. So out when you check this, you can directly say that this will not work. But second point, if you see, second point, if you check, a number is there. So number is however working because by your system can understand, okay, this is a number. Still, I can change this 5 to this 5. But how can I change this hello to a numeric or hi to a numeric or any sequence of character to a numeric or float? This will not work. This is not applicable. And in fact, the best part, when you read the error, it is clearly explaining you could not convert a string to float. This is a string to float. Similarly, if you try to use integer also, it will give you that exception. It cannot convert this string to integer, okay, with this base type. So that's what is your conversion. You have to double sure while doing this. Assignments we have seen already, how we are assigning one by one, how we are assigning multiples, you are assigning in the single line. So this is A is mapped with 10, B is mapped with 5.5, C is mapped with ML. This is already known, this is already known. Then storage locations, we have seen this point, how we are storing any value to a variable X to Y. Okay, and then we are checking their address memory locations. Data types. This is very important because before starting any value, any input, you should know what is their data type. That data belongs to which type. Now, every value in Python has a data type because without data type, we don't have any data. We don't have any value. Since everything is an object in Python programming, and one more thing to remember, Python is functional programming, and in any functional programming, your your object, okay, your all the values, all the data members, all the functions, all the variables, everything is object. So functional programming is known as object oriented, and hence Python is also an object oriented programming language. Everything is object in Python. A variable, a value, a data member, a function, a block expression, everything is object. Okay, I'll explain this object and classes other thing when we discuss about OOPS. But for now, OOPS, for now you can understand what is this object. Data types are actually classes. So we are seeing integer, float, string. These are all your data types. These are all your data types. And these are classes. So we're referring this thing as our classes, and variables are instance. Variable means I am saying a is equal to 10. So we know this 10 is integer. This 10 is integer, but this 10 has been stored in a variable a, which means this 10 is your this 10 is your integer. Integer is a class, and this a is a variable which is object. Because you can see this 10, you can't see integer or other thing. This is not visible for you. What is visible for you is this a. So what you can see, what you can feel, what you can touch, in fact, we can call that as an object. And object is nothing but, if I go with a bookish text description, I can say object is an instance of a class. Object is an instance of a class. That's what we can define. Our instance is in our object and classes. So let's just start with a number, because we started with a number. They're also integer, float, all these are part of your numbers only. Integer, floating point, this too is known to us. There's third type of data, which is a complex number, again coming inside number. So there's three things we have in Python. We can use the type function to know which class a variable or a value belongs to, and the isInstance function to check if an object belongs to a particular class. Okay, so let's not go to this description. Let's see the practical. I said a is equal to 5. Now you can see this 5 is a string because single quote is there. Then we said 5 is of type A. So which means this is a string type. It will print us this is a string type. We are asking from our isInstance function this A which is a 5, which is a string. We're asking is it integer? So obviously this is not integer, this is a string. That's why I'm getting this answer in Boolean as false. If I write here instead of int str, then it will say me true. So isInstance is what? This is actually checking your object belongs to a particular class or not. So integer is a class and a is object. Now, can I write this belongs to a string of actually? If I type this enter, I'll get the answer as true because this str is my class and this is object which is having the string value. That's why. So isInstance is checking the relationship between object and classes. Okay, hopefully this is clear. Second point, a is equal to 2.5. So I said a is of type A. 2.5 is of type, what is this? This is float. Whichever value you see in decimal is a float. Okay, so to get more insights of it, you have to take so many examples. Start writing this, start open Anaconda, start using this all practicals. Maybe you can take other practical. So most of the question statement or example we have extracted from python.org site. If you guys want to read about their more conceptual part, I'll not recommend to go to read any tutorial. The best thing is this. You can go to www.python.org site, which is your Python official website. You will find here a documentation, and within documentation you will find tutorial. And in tutorial, if you click, you'll get all the solutions. Everything is there, all these examples. So for theoretical points or few practicals are also there. Definitely you can go and read about it. Next part is 1 plus 2j. This is the complex number. So integer and float we have seen. Now we are checking for complex number. We said 1 plus 2j. Now 1 plus 2j is 1 plus 2j is a complex number. So whenever you want to make any number as a complex number, you will have to use this j. You can use anywhere j plus 3, j plus 3, 5, 35 as in j plus 3j. You can use like that, but only j is a complex number. Okay. So we use sometimes this calculation 2 plus 2j, very seldom, not often we are using it, but seldom we have this kind of complex calculation. So when we need a complex calculation, we'll be using this complex number. Okay. So 1 plus 2j, if I'm checking what is the type of this will tell me complex. And then I'm asking, is A belongs to complex class? Yes, A belongs to complex class. I've written it complex and I'm getting answer as true. So this is your number. In nutshell, three things: integer, floating point, and complex number. Second is a Boolean. Now in Boolean represent the truth values false and true. So in Boolean, we'll be getting these two things, false and true. A is equal to true. So you write this in T uppercase, true. Print type A, you see this is a Boolean type and you're converting this actually Boolean. So you can obviously convert this Boolean to their other data type also, string, float, integer, all this thing can work. When you convert this to a string, you see b1 is equal to stra, and when you print this b1, you get true. This is now a string, which means if I check this b1 is represented as this true. That's what it means, because you're writing str. This is a type conversion. Can I check with other thing instead of this? A string, can I write this integer? So before going to tell you the answer, let me write one thing. Now, Boolean we call true is Boolean value, false is Boolean value. Human has given interpretation for this numeric. True is known as 1, false is known as 0. And in medical domain, we call this is positive. So currently is the case of COVID, we call somebody is positive. So we can represent that with value 1. If somebody is negative, okay, the person is not having any sugar level, any BP level in medical fraternity we're using. So we will call that person is having negative. We can say the same number, the person has a 0 value. All right. So this is the 3 interpretation. Now, if I convert true to integer, I'll get 1 in place of true and false will be 0. If it is float, I think, if it is float, it will get 1.0 and 0.0. Can we try and check this out? Yes, this is 1. Can I convert this to float? And I see this is 1.0. Similarly, I can apply this here also, integer and float 0.0. So this is about your Boolean thing. Remember these 3 points: true 1 positive, false 0 negative. After this numbers and Boolean, third we'll check about string. Now string is a sequence of Unicode characters. Okay. A few more definition we have. So we can use string with a single quote, double quote, anything is fine. This representation. A string in Python consists of a series of sequence of character, letter, number, special character. So within this code, you can write anything. You can write absolute number, you can write decimal value, you can write Boolean value. Everything will be considered as a string only. A string can be indexed or subscripted as well, which means if I want to access the string value, I will access them based on their indexes. And always remember, in fact, you can make a note whenever you see something like this indexed. So index always start, people who are coming from software background, they already know index always start from 0, always start from 0. People who are seeing this name first time, okay, so index, if you have total 5 number, 1 2 3 4 5, okay, 5 natural number, if you are indexing them, you'll read them like this: 0 1 2 3 4. This is actual value, and this is your index. So remember, index is always n minus 1. Always, if there are total 10 number, it will be index is 9. So index goes from 0. This formula is enough to remember n minus 1. Now, similar to see the first index of character has a string has to index with 0. That's what I've written here. Index will start from 0. So let's read few things. This is online ML course. This is online machine learning course. We have given one statement within a single quote. Then we are printing this S, and after printing this, we're getting the same statement, which is okay. Now I said S0. This concept, what I'm writing here, is also known as a slicing. Well, I have given some example of slicing here also, but both are kind of same thing. This is very easy. You'll see it. You'll find it easy thing. Now S is my variable name. 0. The 0 is index. Can we read this now? So T, this is the statement, and it is starting from T. So I'll read this as a 0. That's what I said. My index will start from 0. 0, 1, 2, 3. Your space will also be counted as a 1 byte. Remember, this space is also counted as 1 index. Do not exclude this. This is also included. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So total 23 to 24 elements we have. But this is very critical to remember or to count all the value. What is the easiest method I can tell you? You can do one thing, you can check their length. Okay, so first I'm checking their length. When I'm checking their length is 24, so I know this index will go from 0 to 23 because that's what I said. This is always n minus 1. Index is always n minus 1, which is 24 minus 1, and that's the number. So S0 is giving you T only, length of S is giving you total 23, and S, this value, you are saying 0 to 5, 0 colon 5. Okay, 0 colon 5 means start from 0 and take till 5. So 0, 1, 2, 3, 4, 5. It will take 0, 1, 2, 3, 4, 5. It will exclude the last one. When you type this 0 to 5, it ideally asks, I need from 0 to 5, but last value is excluded. Remember this. If you type 0 to 10, this 10 will be excluded. So you'll get only 0 to 9. That's what internally it means. So if I'm 0 to 5, it is printing me actually tell this is space. It should print me I also, but it is excluding this. So it is taking me from 0 to 4. Okay, that's what the answer of this 3 lines are. Then this is also important. Slicing. So this is a slicing only. You said S and you want to take till 5. So you said colon 5, but you have not defined here. If you check, you have not defined your front value. So what do we mean by this 0 colon 5? Let's separate them. So 0 is your starting point, and 5 is your stopping point. So 0 to 5, it will go excluding the 5. If I'm doing this S colon 5, so colon 5, this colon 5 will be excluded again, but since there is no starting point mentioned, it will by default start from 0. So it will read this as a 0 colon 5. Okay, you have not written the print statement, that's why not getting the output. Let's get this stored somewhere in X variable and try to print this. If I print this X, see what will happen, and maybe you can store this to Y and try printing this Y and check what we get here. If I print this, you can see it here. This is 0 colon 5 again, starting point 0, 5 is ending point or stopping point. Then S is variable 2 colon nothing. What you are getting here, you can check it here. Y is equal to this S, which is having this statement completely. Then you say 2 colon. Now your starting point is 2. Let me break them. So 2 is a starting point. Always read like this. And this is your ending point. But since ending point is not defined as a stopping point is not defined, it will read till the last character. Okay, so 2 is a starting, which means 0, 1, 2. So it will start from I, this I, which is in second place, and it will go to the last character because there is no stopping point defined. So this is how your slicing concept works in string. Hopefully this is clear. When we select some data point or some number of column or some number of characters, this is very useful. So make a practice of it. This is just one set of slicing. We have some other set of slicing also. So currently I'm not going in deep about data types. I'm just talking about the data types so that we can fit this with some conditional expressions, some operators. We have the separate topic for all these points. Okay, so string has a separate, number has a separate, your other, this list and other thing are separate. So this is just like uh, an introduction. This is just like a teaser for us. Okay, how this data type can be created. Now Python list is an ordered sequence of item It comes under collection, by the way. It is one of the most used data type in Python and very flexible. All the items in a list do not need to be the same type. I'll not read this complete statement. Let me highlight a few points. So we're talking about list. Point number one, which you should remember. This will follow the FIFO order, first in, first out. Second, they are mutable. So I can change their length. I can increase or decrease their total size. I can change their existing value also from any index. Third point is list can store data from same type. List can store data from same data type or similar element, I can say, and mixed data type also. So I think this is more clear. Same data type means all the values are integer like this 1, 2, 3. Okay. Mixed data type means maybe 1, then 1.0, then within this we have 3 like this. This is what is your mixed data type. You have integer, float, and string. Okay. So list is actually a collection of element. To dealing with a single element, we have this number, string, float. But if you have large number of collections, okay, large number of element, you cannot define them in an individual value. You have to create a list for that. So declaring a list is items separated by commas are enclosed with this bracketian. Yeah, very important. The fourth point, the signature or the sign for this list is square bracket. We'll be writing all the element inside this single bracket. So very important to check this float. List thing. Let's see a few example. So here I'm writing a is equal to 10, which is integer. This is float. This is string. Now indexing always start from 0. So this is 0 index, 1 index, 2 index. When I'm printing A1, this will print me 20.5. We said this is mutable, which means I can change them. So obviously from 20.5, if I change this first index, which is this index, and I want to change this value from 20.5 to 23, and I print this, so it will change 20.5 to 23 and return me this. Then you are adding one new element, and this is all following the order. It is following the order sequence of items. Okay, so how this is storing? They're storing in first in order, right? First in, first out. So this is your three values already present. When you make one more entry, the next entry will go to the last index. This is what FIFO does, first in, first out. Now, when you print this after adding this value, so you're writing here a plus is equal to 5. Can we read this? Can we break this statement? This exactly the same thing. You're trying to add one more element in this existing variable, existing list. So you're saying that this list is already with me. I want to add a new index, which is 5. Okay. It doesn't mean that you're treating this as a scalar and then you're adding it here. This itself is index. So if you check this out, you have 10, 23, hello, and 5. This is printed. When you check a2 of 2, okay, read this carefully. When you say a2 of 2, what you are saying, you want to check first second index, because if you said this 2, this 2 means this index hello, and from hello again you're saying I need this second index, then 0, 1, and 2. Can I read this hello in index wise 0, 1, 2, 3, 0, 4, 0, 2, 1, 2, 3, 4, right? So this L is 2. When you're saying 2 of 2, so hello is second, and then hello of 2 is this L. That's what you're getting it here, this L. So List in nutshell, I can say these are mutable. The sign is this sign. You can change the value, and size can also be changed, can contain mixed data type. Tuple, if you understand list, tuple is very easy because in tuple, it just one difference we have. This is immutable. Rest all things are same as list. So if I compare list and tuple, so I can say list is this sign, tuple is this sign. List is mutable, tuple is immutable. List is or storing data in order in sequence. This is also following the concept of queue before, right? This is the important point. Rest everything is same. They can also contain mixed. They can also contain mixed. Let's see. Tup, this is a variable 12020. So you can see the bracket. Always check the bracket to identify whether this is list or tuple or any other data type. Since there is the normal bracket, I can say it's a tuple. 1 comma 20 comma this is integer string mixed data type. We can see it's a tuple because of this signature. Then t is equal to 1.5 ml. We have given integer float string. Then we have given t2, which is 249, all integer. We are checking the type of t. This is tuple. Then we are creating one new variable where we are storing this two tuple in the list. So this is known as, we can call this as a list of tuple. So we have multiple tuple stored in the list. And how I'm knowing that this is a list or something else? Because you can see this is a square bracket. This is a square bracket. In the square bracket is a sign for list. Very small thing, but very important. So within this list sign, you're storing T and T2. T is 1.5 ml and T2 is 249. So 1.5 ml and 249. This is your output. You can see it here. So both this tuple is stored inside this list, and this is what you can get it here. If you're checking what type is this, so after printing this T1, what type is this? This is a type of list, obviously. If anything is storing within this bracket, we can call this as a list. Afterwards, T101. Now I'm saying from T101, so T1 output is this output, okay? T1 output is this output, and from this T1 you're saying 01, which means zero index. Okay, so let's read them separately. Here I'm just writing this thing 1.5 and ml. This is your first tuple, this is your second tuple, and you have stored this inside a list, right? Then you said 01. Now this whole thing, let me change the color. This is index 0, this is index 1. Or if I read them in a matrix wise, this is the multi-dimensional array. Oh, I can say multi-dimensional matrix 2 by 3. I can read them 2 by 3 because 2 row I have 1.5 ml. This is another way of representation your data, because in machine learning we'll be doing this row 0, row 1, column 0, column 1, column 2. Now when I'm saying 0, which is my first row, okay, which I can read as row 0, and then I'm saying I need a first index. So you can read like this: row 0, column 1, row 0, column 1, which means I'm talking about this thing. If you read from here also, you'll see the same thing, because 0 is index for this. So this is zeroth element of zeroth index. This is first element of zero index. This is second element of zeroth index, or zeroth index of zero. You can read this as index also, but index to index will be difficult or confusing to say, hence I'm calling this as element. Zero element of zeroth index, first element, second element. Now, what is the first element? This 0, 1 is exactly the same thing. You're looking for 0, 1, which is this 1.5. And hence you're getting this answer as 1.5. If this is critical for you, I've given you the second approach. This is number 1. This is number 2. You can check anything. You can create like matrix and read your data like this. Then again, I'm printing this T1, which is giving me the same output. Moving on, T1. So when I say T1, I'm getting 1.5 because, one second, I'm getting T1 for 1.5. One second, actually this should give me different answer. Okay, actually this is giving me this one. This is T and this is 1, first index. Then I said this is immutable, but still I think to challenge this Python and want to see what error they display me if I try to assign a new value to their index. First, they define me one type error and say tuple object does not support item assignment. So if you read this statement in English itself, this is clear that mutability is not possible here. So item assignment does not support means this is immutable. Okay, that's what we have written in tuple, that this is the immutable types. So after this, tuple will see the concept of set. So this is just guys teaser. Okay, we are only seeing because I may be using this kind of concept a bit in conditional expressions or maybe operators. That's why I'm explaining this. But the large portion is pending here. Large portion we have after conditional expression. So we'll see this tuple. There are so many function for tuple. There are so many function for list. All things we'll see one by one. Python set. This set is coming from math only. This is a basic math category, and in quickly differentiate between these four things. So far we have seen three things. So let me write it here. List, tuple, set. List sign, tuple sign, set sign. List is following order of sequence of character, FIFO order. They are not following any order, no order. Then list is mutable, tuple is immutable. They're also mutable. I can increase their size. Then they can have mixed. Mixed is common for all. They can also have mixed element. They can also have mixed element. But set contains one unique property that it does not allow any duplicate. So I can write it as no duplicacy. It does not allow any duplicates. It only contains the unique values. Okay, it only contains the unique values. If I write 4 times same number or same value, it will only consider that once, not multiple times. That's what is a set. Let's see it from here. A is equal to, we have given the sign of set and written this numbers. And if you see this 10 is repetitive, 10 is repeating, then 40 is repeating. When I'm checking A, so let me execute this actually. When I'm executing this, I'm getting, and this is not following any order. If you see, this is not neither in incremental nor in descending order. Okay, so no order here. It is printing me some random value of 5, 10, 40, 10, 20, 30, but I'm not getting 10 or 40 repetitive. This is what I'm calling as a contains uniqueness, no duplicacy. Is instance type of set? So yes, they are type of set. They are type of set because of the signature. When I'm checking their type, it is giving the same thing. Then if I'm trying to add any number here, okay, I said S is equal to 10, 20, 30, 30, 30. So 20 is repeating and 30 is also repeating. Ideally, it should give me answer as 10, 20, 30, which is this print statement. And after that, I said add one more element, which is 11. So 11 is new, no repeat. We don't have in this 11 present in our variable s. So 11 will be entered here to your existing variable, which is s. So it gets one entry and give you a new set. So if you're able to add this, which means this is mutable, this is mutable. But if you try to check their one, if you try to check their one index, what we are saying, set does not maintain any order. If they do not maintain any order, then how can you check their index? This statement itself is saying the second statement. So if you're trying to print this, will get exception. And this exception says clearly, set object does not support indexing. So we do not have any support for index operations here. Okay, we do not have any support for index. You can't access index directly in set. So obviously you can't change the value based on index. You can add or you can subtract. These two operation will work in set. So far, three data types we have seen. Now dictionary, and then after that we'll see the conversion. Dictionary is an unordered collection of key value pair. So fourth data type is dictionary, and people when they start Python oftentimes they confuse with dictionary because this dictionary sign signature is very similar as set signature, but remember this dictionary will write their data in a key and value format. This is applied with a collection map concept. This is one of the fastest algorithm built on the hash function side, which we are calling as map. Dictionary is working based on that concept only. It has actually inherited that. So dictionary will be very fast and all the value we can access based on the key. So those who are interested to know the deep dive of this part, I'll be covering this part in algorithm, data, time and space complexity trade-off or algorithm. But meanwhile, if you want to search, you can search about this concept as functions. You'll find this mapping key value concept inside the hash functions. This is one of the fastest approach, I must say. Dictionary is storing data in key value. This is just element. Okay, so signature is not uh, changing anything. We just have to remember what values we are inserting inside this dictionary. Quickly, we'll see one dictionary. So dictionary is an unordered collection of key value pair. A few points here also I will write. No order they maintain. They are immutable. Sorry, they're also mutable. They can have also mixed data. Key can be integer, value can be string, or vice versa. And this is major properties for dictionary. And searching is very fast. So we can write here as point, search is tremendous. Now d is equal to, d is a variable. D is equal to a. First see how we are writing it, how we are adjusting this point. A is A colon apple, B comma B colon bat, 1 colon India. What does this mean? A colon apple, then comma. So read this whole thing. This is key, this is value. This is key, this is value. This is key, this is value. So I can read it as K1, B1, K2, V2, K3, V3. Okay. So K1, if you want to access their value, now in key value concept, one thing is important. In dictionary or anywhere in the hash function, since we are learning Python, so I'll refer it as a dictionary. In dictionary, key can never be duplicate. However, values can duplicate, but key should not be duplicate. One thing and very important. If you try to if you try to do that, you provide two keys which are same in one variable, you'll get exception. You can try that. So A is apple, B is bat, 1 is India. All the values which are seeing first is the key column, the value. If you want to access their value, you always refer them based on the key. So if you type DA, you'll get apple because A is a key for apple. Similarly, if you want to change this apple to mango, this is what is immutability. If it supports, one second, D dot. It should be this, okay? Yeah. So D is equal to A column this. I have written DA is mango. What do we mean by this line? So in this line, first print statement, I am printing what is the value of A, which is apple. Then I'm saying I want to change this value of A from apple to mango. And I have given my variable name, which is D, then A within this bracket. So A value we are changing to mango. Earlier it was apple, from apple to mango it has changed. When I'm printing this DA, it is printing me mango. So this is the output of print statement. Then third print statement, I'm saying D1. What is the output of 1 is India. So we'll get as India. And then I'm saying last D10. So I have added one more key along with a value. Here I say 10 is a key and US is a value, which I'm writing in the existing variable D. So if I check D10, it will print me the value again of 10, which is USA. So you can access the key directly. You can change their value. You can add new key. In all short, they are following these four things. This is the sign. This is they're not maintaining any order. They are mutable. They can contain mixed values. Now, last few things before closing this. So conversion between data types. Now, just like we have seen conversion between our float, integer, then string. So here also we have some conversion between our data types. And what is that conversion? Let's see. I can convert, so this conversion we have seen already. Float, this 5 is integer, so this is integer to float, this is float to integer, this is integer to string. We already have seen these conversions. But if I try to convert this string into integer, obviously I'll get error because 10 is known to my system, but my system does not know this p. How can I convert this p into number? And hence, if I try to do this, this will throw me exception. Then user is equal to, I'm taking some name. I'm writing this in the line. I'm checking their type. So what type is this? The type of line is coming as, it will come as integer. When I print this, then I'm writing these things. So one thing I will tell you, which is important, user Nilesh, this is a string. What value you have stored is a string. This is integer. Print type lines. You're checking this is what type, this is integer type, you're getting the right answer. Then you said print congratulations plus user. This value will come here. User plus you just wrote. You have given just one statement within double quotes, so you can write anything here. Type, str lines. So line is there. Why don't I directly write the lines? Why I'm writing this str? This is point to discuss. Why I'm not writing directly this line? Why I'm writing this str? Why I'm doing type conversion? This is what is a type conversion, and you're converting this from integer to a string. And why you're doing this? Because you are concatenating this user and lines value with a string. So a string can only concatenate with a string. A string can only concatenate with a string. Remember this point. Oftentimes people make a mistake here. They just think this should work and they remove this str and then you get the error. The string can only concatenate with a string. That's why, since this is a string, this user value is a string, This is also a string. All the value which are in double quote or single quote is a string. So if you want to add any or concatenate any integer or float, you have to first convert them. This is one option. I'll give you another option. Suppose you want to write the same thing using different approach, you can do this. You can do this instead of writing the plus statement. This will also work. So here, because you're not doing concatenation, you're just giving comma and comma. So comma will work, or if you're using plus, then conversion is important. Always. If it is a string, it will only concatenate with a string. So it's a little bit of tongue twister. Then we can see the next. We can convert one sequence to other. This is perfectly fine. You can convert list to tuple. You can convert list to set. You can convert tuple to list also. You can convert tuple to set, and vice versa. You can convert set to tuple. Before tuple, let me say list, and you can convert this set to tuple. So all these things should work. Let's try this type conversion of your list, set, and tuple. So 1, 2, 3 I have given, and then I said print a, type a, s is equal to tuple a. So I'm trying to convert this set. I'm trying to convert this set to tuple. Again, they're checking what is their type and printing this. Okay. Read the output. First, it is set. Then converted the set to tuple. This print statement. So first print we're getting output, then we're getting set, then we're getting tuple, then we are getting the tuple form output, then we are converting this set to list, then we are checking the type, then we are printing it. So I have just given example of set. This set is converting to list and tuple. You can check with all these options: list to tuple, set, tuple, list, tuple, set. All this option should work. This is pretty much about your different data types. And last one is, if I want to store this string in a form of list. So I have this also. This is like string to list conversion. String to list using list method. So in list method, I have given this element, and when I'm checking their output, these are considered as a different indexes now as the main property of list 0, 1, 2, 3, 4.